All right. Good morning, everybody. This is the February 2nd. Wow, we're in the second month of 2021 already. This is the February 2nd recording of the Cluster API provider nested office hours. This meeting is being recorded and we post to YouTube, so please make sure you don't say anything you don't want posted for the whole world to see. And we can get started. There isn't a ton on the agenda, so make sure that you go add yourself to the attendees list. If you're here, I dropped a link into there. I'll drop another, just make sure that it's at the top for everybody in the chat in Zoom. As well, if you have items that you'd like to add, please make sure you add those to the agenda. Sweet. And I think for right now, the first one, I don't know, Chow, would you like to talk about the nested etcd controller that you created so far, or do you want to?
Yeah, I can start talking about it. So, last week I implemented the nested etcd controller. There are still some minor issues left, but I think I generally finished the nested etcd controller, and I have already tested locally. It works as expected, but when I implementing the controller, I run into some problem or issues, or maybe some features I require from other controllers like nested control plane controllers. So I think today we can discuss all these features I think need to be complete by the nested control plane controller. And Chris can give me some suggestion if that sounds reasonable. So the first one, when I try to implement the nested etcd controller, the problem is if you guys remember, maybe I can share the screen. That can be. Do you think I can share the screen?
You can. Let me make sure and give you access to do that real quick.
Share screen item is green, so I think maybe I can do it.
All right. You want to give it a shot?
Okay. Let me try to share the screen.
Try it again. It probably will work now.
So could you guys see my terminal?
Yep.
Okay. So let's see this. So if you guys remember, when we define all this nested CRD, we put the nested common spec, component spec inside each nested component spec. So inside this one, we have borrowed some fields, some destruct from the KubeBuilder declarative pattern repository. The first one is the common spec. So we used to think we can use this one to the version, and there are two fields inside this destruct, the version and then the channel. And I think we are going to use these two fields to specify which templates we are going to use to create these components, right, Chris? So, yep. So I'm not sure how to do that actually. I cannot find any working example online. So currently, I just not implement this part. So if you guys can see on the right hand side, I just don't do anything to.
Gotcha. So you're just loading up the actual resources in as YAML and then parsing them and then applying them to the cluster that way.
Right. Correct.
Cool.
So
okay.
So right now I just do nothing. So I assume that if the version and the channel does not set by the user, we are going to use the default templates, and we are going to host these default templates under the Kaplan repository. That's what I think. So currently I only achieve this part using the default template to generate the nested etcd component. So I wanted to see, do you think we should support the version and a channel feature in our first release or first version?
We can probably hold on this if you feel like it's. So I added to the office hours agenda doc. I added a couple notes as you're going through this. So for usage patterns and for usage of the declarative pattern stuff, there's a whole repo of examples that I dropped in there that should specify how to structure these and how to use the declarative patterns like reconcilers that are pre-built.
Okay.
That might be something to check out. I'm definitely open to the idea of moving forward with what you have if that does not fit those. If that does not fit, yeah.
Okay. Okay. Sure. Okay. So.
Because that'll give us the ability to sure. Have a single controller that can suffice for 118, 119, 120, 120, so on and so forth, all at the same time. Okay. I guess we technically don't have to. Vince, you have your hand up.
Okay.
Yeah. So I didn't see like a cluster add-on for etcd, except it's probably like at the best control plane, but from experience in cluster API with the kubeAM control plane, like etcd is really picky on how to do your operations. So I'm not sure if like it would work out like in the end, like to have a generic controller that does those things. As an example, like in 118, we had to like do a special case like for etcd to like only upgrade in a certain order. So we might wanna, I do like the suggestions, like maybe just start simple right now, like learn from that, and then like maybe we could move to a better pattern later. But also hi everyone.
Yeah, thanks for the suggestion. Yes, we do think a general controller cannot fulfill all the final goal, because we know that there are a lot of like etcd controller out there, like different etcd controller. They are using different kind of CRD. They are using different logic to generate the etcd component. So this one is like a very basic, very native one. So we assume when user does not specify any does not specify any specific etcd controller, they are going to use this very native one, and it's going to create a etcd container cluster, a cluster on a super cluster as basic in the container. And in the future, we think each vendor or each users, if they wanted to use some more powerful etcd controller, they should stop this native small controller first and then use their own etcd controller to do their jobs. We just wanted to have some like working example for the first version.
Yeah, make that first run experience at least useful, and then allow you to use more advanced controls later as you start to build out your solution using this.
Yes, correct.
Yeah, I think have a default is definitely you need to have a default anyway. So, but for the common spec version and the channel, my original thought is the version is just indicating the formally released etcd version, and the assumption is if you only specify that string number 1.14 something, and the assumption is we already have those templated ready in our Captain repo, so that version you just use to define. If you don't have that particular version in our repo, we should just give an error so it doesn't support. And an assumption, and assume that channel is even flexible. People can use that channel according to a customized YAML for the etcd if it has. That's my original thought. Is that correct?
Yeah, that was what I was going for with that. Yeah, because then you could mount your own slice of files into this controller and technically apply whatever you wanted. If you wanted to swap things like crazy, you could.
Yeah. So
the main thing that breaks down there is the RBAC rules and what you actually grant that controller access to, which is something that the add-ons group has already had some run-ins with, in terms of like, if you make it so that it's so flexible that you can apply any type of file to it, ingress, service, secret, config map, so on and so forth, that controller needs to have permissions to do all of those, which can be kind of a little bit scary, but that ends up being on the provider or on the implementer anyways.
The channel, you just put a YAML file, you can put everything in my YAML, and I think the controller just blindly apply every YAML, including RBAC, whatever services you have. So,
Yep.
So that's totally doable. And coding wise, there's no much complexity compared to just apply another YAML. So yeah, I don't worry that part. So as long as we have the default, we can easily extend to support at least a version. The channel part is maybe later, but the version part, we can have a few building templates. So far we only have one. We can add a few others if you like.
Yeah. Yeah. The other thing about channels is it's more just it's a string representation of just like of whatever the latest version is or something like that. You can think of this as stable is the channel, and so that would be whatever that most stable version is deployed into that operator. Think latest as you would in Docker images or runtimes. Probably don't want to use it that much, but it's at least something to get you started.
Okay.
So
yeah, I think as long as we agree that because yesterday I asked Charles, so whether we want to have we have a separate EDCD controller or just use one but implement the interface to allow the integration. So I think I kind of remember we have a conclusion in the past that even people may just follow the same API but implement their own controller, like completely swap. So I think that's also okay. Making the native one pretty simple and neat and just do the minimal job for the native one. That's also okay to me.
I was muted. Luckily, we're at a place where we have some flexibility that we can make mistakes and roll back on those too around this, since this is completely new. So yeah, as we move forward, I think choosing one to go with, making sure that validate that works as we go forward, and don't go through any one-way doors that we can't go back on. So cool. This is awesome. I'm stoked that to see this. I gave it a very, very short review. I only had one single nit in there, and then I wanted to just open the communication here. You did have one thing that I added as an agenda item, which Vince had some feedback on too, related to what you were talking about certificate management and how we probably need to actually do that at the NCP controller.
Yeah. Mm-hmm.
Now, before you go into that, or actually give the background on that, I think would be useful.
Oh, okay. So we used to think each component should generate their own PKI resource by themselves. And the cluster API do provide several general secrets for store all the CA root certificate. But when I implement the nested etcd controller, I run into some problem, and I think there should be a central controller, specific controller, or nested controller plan should generate all these PKI resource in advance. Because when we start the nested etcd components or start an etcd, we have to load in the API. We need to load in the CA of the API server, because when etcd start running, it may receive the request from the API server, and it need to use the CA, the API server CA, to authenticate this authorize this request. So I think there should be a specific controller or nested control plan controller should generate this PKI in advance, and then we can start creating each nested component. What do you think, Chris?
I think that makes sense. And Vince, I popped this question over to Vince right before this to ask how the rest of CAPI providers do this. Can you give that background for everybody, Vince?
Yeah, so I'm primarily going to talk about like the in-tree bootstrap and control plane providers. So like you might have heard like KCP, which is the kubeadm control plane, and then there's CAPIK, which is the bootstrap for kubeadm. CAPIK actually generates the certificates today, and we're trying to move that around. Like I don't remember, but like if like we actually moved it or not. But as you mentioned, like we do generate the CA, so like the main CA, which has like a 10-year expiration date. Hopefully, like you're not gonna have that cluster running for that long. And then KubeADM actually generates like the certificates for when you run KubeADM init, for example, or join for etcd, control plane, etc. So you have to replicate some of that logic, which is already available in KubeADM for that. So it uses the CA to generate those other certs. The etcd certs are passed in to KubeADM to actually use those as a base. So Cluster API already has like most of these available, and then these will get stored in secrets. The nice thing about it is that like if they're already in the secret, we just use them instead of like creating them, so that the user can supply their own. Today, that is not its own controller. If you want to go like that path, I would just use Cert Manager at that point and just create that CR to say like, hey, I need a certificate, and get us the certificate back from Cert Manager. Now the CAPI in Alpha 4 is going to move to Cert Manager 1.0. That's actually a great way for us to segue into this, because that will give us like a long-term stability for those APIs, the V1 APIs for Cert Manager. So there's like a couple of ways to tackle this problem. I would suggest to like try to replicate as much as possible what CAPI is doing upstream today, mostly to kind of get in line, because if at some point like we merge and we meet at, yeah, that would be like a great way to integrate. Does that make sense?
That makes sense to me. Were you saying, just to clarify one thing though, you were saying that in V1 Alpha 4, it's moving to Cert Manager 1.0. Does that mean that the long-term plans for like the KCP implementation would be using Cert Manager too?
I don't.
Or is it just an option? Like you can create the cert. Okay.
Like I don't think we'll change the certificate process as it is today, like at least for the foreseeable future. Especially because this can be just an internal change. Like users won't have to see how we get to a certificate. It's more like now we'll do it in a different way than before. But the end result is like we're gonna have the secret somewhere in a secret, like and with a prefix name predetermined.
How's that sound to everybody else?
So I'm not quite familiar with the certificate manager. So if we are going to use the certificate manager, does that mean we still need to generate the CA secret by ourselves and then store it into the secret, into the central secret, the global secret, and then the certificate manager will read the CA and generate a corresponding certificate for different components?
If you, Vince, do you want to take that? So I believe, and correct me where I'm wrong, the idea there would be you would use Certificate Manager to create an issuer, and this could be outside of the actual implementation in the nested or in CapN, because it would be, you can go and deploy certificates using Cert Manager, which you just deploy an issuer CR, and then you deploy certificates that reference the issuer, and that generates, it can be CAs or keys and certs, and that certificate resource would go and have a secret name in the actual spec that defines what secret it's gonna get created as. And so I dropped 2 links from chatting with Vince before this to the 2 cert implementations in the KCP. So it sounds like the idea would be continue to go forward with potentially reusing what we have in KCP, but always make sure that it's always supporting the proper secret names that CAPI expects. And if a provider wanted to and already has Cert Manager deployed, they could deploy those. It creates the secrets for them, and it's kind of outside of the CapN's scope, but it at least would work. And then the internal could use the KCP setup as long as that fits what we need, and it doesn't, and we don't have to hack too much of it since we're not using KubeADM's bits.
Okay.
So yeah, I'm okay with it, but I think a few concerns is, does that mean that if people want to build a KPN and we see from scratch, he has to install Cert Manager? Is this
No, the idea would be it's just an option. It's just that we support it. You'd still have the built-in entry like what Chow's already doing, but instead reusing some of the CAPI functions for it.
Yeah, but for the entry, then who is going to do that? So yeah. So for
Great
entry,
question. We probably should file some radars sorry, I'm speaking different languages right now. We should probably file some issues on GitHub for those. Oops.
yeah, yeah, exactly. So I think that sort of measure is pretty straightforward in my opinion. It's just you just have a contract about a secret name. That's all about it. And, you just assume it exists there. If it doesn't exist, using the building one. But for the building one, I think for Charles, the original question is who's going to create a building one, right? I think this problem is kind of tied to the I would say the NCP control plan workflow. So somehow, well, we need to define that workflow first and to see where is the best place to inject the CA creation. You know, intuitively, I thought it should be happening in the NCP control plan. If it is decentralized in orchestrator.
I think you're right there, or I agree at least. So I put a note on because I have pull request number 30 is open right now, which has like the first draft that I wrote, which was pretty lightweight of the NCP and NC docs. That still is posted as a draft in GitHub, but I'm open for reviews. I added a comment after reviewing Chow's PR for the nested etcd implementation that we should probably add the certificate management stuff into that. So I'll spend some time and write up what that looks like so we can get that in place. For the time being, it sounds like, it sounds like we could potentially go down the path of within the nested etcd that you already have. If you want to, if it's easier to keep that implementation of generating the certs in there, we can move forward with that. Or if you want to just basically put in the checks to see if the secret exists, and for testing, we just use cert manager for like the time being to just make sure those secrets are in place. And then we build out the proper implementation that lays the secrets down. Whichever way you want to go, I'm open to both. We would probably just pull out the entry implementation and replace it with KCP in the long run.
So.
Okay. Yeah, I would prefer to second one. So don't do. So if we agree that nested controller is not the right place to generate row certs, so we should remove those code. But even we can make assumption that whatever the secret exists, you can just mark them or pre-create them during testing, which is inconvenient in my opinion. So which also means that if we want to, the next immediate controller we need to implement is a PKI related controller. We need to do it in the first before we implement the rest of the thing. Otherwise, we have a long dependency chain on that. So
for sure, that makes a lot of sense. Yeah.
I think I would suggest get rid of the PKI code in your current PR and just assume the secret is there.
Okay. Yeah, that makes sense. Yeah, I will remove the PKI implementation in this PR and assume that there is a secret that's already being generated, and I will check the secret if the secret exists. Okay. Chris, do you have anything wanted to add?
No, I just wanted to say that sounds good to me. I just added those notes to the agenda as well. That I'll go back to the NCP doc and make sure to fill out what that's going to look like for generating certs.
Okay.
Vince, I'll probably poke you a couple more times to get more information.
So just to clarify, does that mean like the user has to create the certificates on their own?
For right now, until we get the NCP controller in place, but we don't have any of the other component controllers built yet.
Okay.
So for testing the etcd implementation, you'd have to generate the certs, and then call the nested etcd apply a nested etcd CR, and then once we build the NCP controller, that'll lay down the secrets for you, and you don't have to think about it in the nested etcd implementation.
Okay, yeah, that makes sense. I was looking at KCP. Actually, KCP also regenerates the kubeadm, the kube config. If it's like 6 months like before expiration, so you might want to pull that in too. There is like a kube config package. I'm going to link to it that you can find utils in. Here. And I'm gonna put it in chat, like if you want to take a look. But okay, that makes sense. Like I was just like confused, like if we were gonna require like folks to just bring in their own certs all the time, because that can be like a very high bar. So
Yeah, no, not long term, not long term.
Perfect.
Agreed. Okay, so the link that you just sent, so that I can make sure that I get this documented. So NCP also, or sorry, the KCP implementation will generate the kube config for you, similar to what we were doing in the VC manager, or what Chow did in the VC manager. So we'll basically do the exact same implementation in. So I'll add that to the NCP doc as well, that we need to generate the kube configs for components. Okay, cool. That's good to know.
The kube config also, like you can get it back with cluster cuddle, with cluster cuddle get kube config. But this generates and regenerates, because that expires after 1 year, if I remember correctly, which is probably good.
Perfect.
Okay, so I have one more features I think in the nested control plane controller should do for other nested controller. The thing is the honor reference. If you remember in the first version, we designed to have the user to apply all this CRD separately. And how to link all this CR together, we are using a honor reference. So inside each nested controller CRD, nested component CRD, we have honor reference point to the nested control plane CRD. So this thing has to be set by the nested controller control plane controller. Yeah.
Makes perfect sense. I will definitely add that to the doc as well. Cool.
Yeah, it took me a lot of time to debug these things, because if you do not set it on a reference and you apply a CRD, it will successfully apply. The kubectl will not return any error, but the CRD will not appear on the cluster anywhere.
Really? Yeah. Okay. Interesting. Cool. That's a good call out.
Yeah, so I think that's all for my PR for now. And yeah.
All right. Anybody else on the call? If you have a chance, make sure you go and review Chow's PR about the nested etc implementation. And then it sounds like you're going to remove the PKI implementation from in there and just expect that secrets exist at a specific location. Okay. Cool. And that'll be from your implementation, or you and I can talk about this after. I just want to make sure that I create all the proper secrets for you within the NCP doc. Perfect. Cool. Does anybody have anything else? We're at the bottom of the agenda.
Yeah, just refresh my memory. So I kind of, let me think about it. So the idea is the user is supposed to create all CRs, including NCP CR and the component CRs, and the controller. There are a bunch of kind of coordination in the sense that the NCP controller need to first set honor reference. Based on my code reading about the child implementation. So if the honor reference is not there, the controller is not going to proceed, right? So then have we discussed what is the right way to link all the CR together? So you know what I'm saying? So how the NCP, so how do you make sure the NCP controller find that this particular component CR belongs to this NCP CR? So that should be kind of the ID kind of thing. So are we using label selector or just use name to do the matching?
So right now in the NCP doc, what I wrote, which is similar, or which is a lot of it was pulled from what Chow was writing at the beginning in the nested component doc, but basically just referencing using object references. So we basically have in the NCP controller spec, we have a namespace prefix, we have a control plane endpoint for the CAPI implementation, and then we have the etcd ref, the API server ref, and the controller manager ref. And so when you have all three of those, it's going to go find the resource and then set up the owner references from that.
Oh, okay. So are we assuming that the user need to provide the roles ref?
At least the names and at least the names, yeah.
At least the name. Is that enough? Use name to find
but it would be There would be API group, kind, and the name usually.
Good call. Okay, so then it would be all three of all of those.
Yeah, so like we usually have templates so that then you can end or substitute like these things so that the like users don't have to like manually put things in. So like this could be like a part of like a release, like you have like a template like that's predefined with all these objects so that you just have to substitute the name of like resources and then it would auto create all these things for you. But we do have examples, like when you get there, like I can point you to the right direction.
Yeah, that's also my thoughts about, is this maybe a burden to let people fill roles field? If because I'm afraid people, because I remember the ref has at least the kind of UID kind of thing. So if even naive people think I need to provide everything, you need to feel, they need to feel a lot of things, but I don't think it's necessary to feel those many things.
UID should never be filled by a user because that changes from cluster to cluster. So like it wouldn't work in a backup or restore scenario, for example. So it would probably just be API group, the kind and the name. And the reason I'm saying API group and kind is that like if someone wants to do a different implementation, you could default to the ones that you have in tray. For etcd control plane. But if someone wants to bring in a different implementation of the etcd nested controller, they could do so. That's why there's that pluggable interface. If you don't want to support that, just go by name. That's what we did upstream for some things that you don't. Does that make sense?
Yeah, so that's probably something that we need to talk a little bit about. If I think this is where we get into the interface versus how we're going to actually support those other implementations for etcd. I think a big piece of that is what data actually needs to get shared back. Because if we do, so correct me if I'm wrong, there's a bunch of field selecting within the CAPI implementation where we're like that's how we're getting the control plane endpoint from any doc, correct? So if we wanted to go that route of being able to select a specific field out of there, say for instance, being able to grab the addresses out of the nested etcd status field, we could do selecting of those using the actual field selector in object ref too. But I don't know if that will support that. That wouldn't really work if we have multiple pieces to select.
I don't know what you mean about selectors. Which
so being able to get like specific attributes from a net from, I don't want to call it a nested, but an object referenced CR. So if there's attributes that we need to share between NCP, etcd, and K API server for a nested API server, for example, because we're gonna have to get the etcd addresses out of the etcd implementation to provide those to the Cube API server CRs as well. And so we need to have that's the big hub that we need to be able to make sure is supported.
One question that I have here is like, are you planning to support like a different implementation of etcd?
That's the goal, to be able to still support it but not have it built in. Okay, so that somebody could replace it.
So yeah, in that case, like you probably definitely need API group and kind. And yeah, the name, like that's obvious. So for I've been calling these data interfaces. So you would use some sort of like unstructured client to like get the object that's referenced somewhere, and then you're saying like this object is conformant if it has these if it has this field at this path, and they're like the unmarshal into a JSON object that you expose. Yeah, that's like what we do in CAPI as well. Like you could look at the machine controller or like the cluster controller. There is utilities there as well, which are not exported today, that say, go get me this external reference, which is a reference that I don't know anything about, but I expect it to behave in a certain way. And that's what you, I think you're
Yeah, that's exactly what I was thinking there. I think we just need to make sure that we know exactly what components we need to be able to get and what those need. I don't have that off the top of my head for what's going to need to be shared in between the two, but we'll want to define what that's going to look like for sure.
Yep.
I know at least its addresses, and we obviously have PKI, but we're going to be sharing that down from the NCP implementation through secrets. So that one's a little bit different. But Chow, Fei, if you have thoughts there on other components that or other attributes that we're going to need to share between those two.
No.
I think
for now.
IP is pretty much, yeah, just look at what is the dependency here. I think it's service class IP and IP, right? And IP, yeah, just service class IP, because the API server has a services post, right?
The other way around, though, the etcd implementation, we need to know about the, you're right, we do need to know about we need to know about how to address it. That's all from that side of things. To be able to give to the Kube API server. I'm trying to think if there's other fields that we need to be sharing between at least etcd and the Kube API server. Similar, we're going to have to do the same conversation between what the Kube API server is going to need to share to the controller manager. For example, like syncing the service cluster IPs or the CIDRs, because those are the same. So.
Yeah, I don't see others, but maybe we can expose them. Move on.
One suggestion that I have like around sharing data is like one potential solution that like we found pretty useful is, sounds awful, but copy data from like where, so if you have an etcd reference and you want to expose to others, the etcd, you said endpoint, or whatever else you want to expose from etcd, I would make a field inside the nested control plane status. So as a status field, not as a spec, that copies that data from there and exposes to others. So like your interface between all the components is always the struct that's shared, that like you can actually unmarshal and it's type safe. So that you have to only unmarshal this unstructured data in one place and then expose it to others. So as more data like comes up, like you may probably want to add more fields, but you avoid like other implementation to also do the same unmarshaling, because then you have these massive strings that like, you know, like are everywhere and you like kind of have to change it like in all places.
That's also sounds reasonable to me. So if the shared information is limited and I think hopefully now they are limited, so we can put in the status at least.
Yeah, I agree. I think that makes sense.
Yeah, the only trouble, but I think we don't have a conclusion right now, is how to do the upgrade. The upgrade, but I believe if we do upgrade, is either the component do their own upgrade, or if we really want to have a centralized upgrade place, which is NCP controller, it is the NCP controller need to do the unmarshal for the customized CR, but at least the components, the individual components doesn't have to do, because they can look at the decentralized place.
Yeah, I'm hoping that we can leave those to the individual controllers doing the updates and those be somewhat prescribed in terms of, okay, I'm going to go update etcd and I'm going to deploy a new CR, or I'm going to update the CR and have that do whatever it needs to roll out. Similarly, allow that to happen with the Kube API server and then the controller manager as individual components. And then still do the sharing back through, so we can have it so that if NCP gets changes, we're also catching that in the next layer. So if the certificates need to be rolled, we update it at the NCP, and that downstream affects everything. Or if the etcd implementation just needs to upgrade to the next minor version, it potentially doesn't need to change anything unless it's changing the addresses on the NCP. And if the addresses happen, then I think that could be a pretty easy tree to work with.
Yeah, I think in the beginning we can rely on component do their own upgrade, but in the end, if you really want to do something, real in the production, anyway, you think about it, you probably will do, the whole cluster-wise the upgrade, which means if your controller doesn't do this, which means you have to implement another rollout controller to do the all components. So upgrade. So it's okay if you think this problem is too, user specific or whatever. We can leave it to the user to implement that. Or otherwise, we can think about have a simpler, centralized place to do the upgrade, to do the exact, define a kind of a cluster version, which means a version of all components somehow. I still feel that it would be a useful feature because for the majority of the user, they don't have that, they don't need that in a sophisticated upgrade for each components. They probably will just do the major upgrade, like Kubernetes goes to 119, 120, just to update at least the API server and controller manager at the same time, right? By one click would be nice. But at CD maybe it's slightly different. So, but on the other hand, we only have two individual component, API server and the controller manager. If you do separate upgrade, it's still okay. It's not that troublesome. But if we extend it or with more, for example, with add-on, if we have a lot of add-on, so I don't know if individual upgrade is okay, but maybe a kind of in reality, people need to implement their own upgrade controller.
Yeah, I mean, I definitely still agree. Agree. The template is going to be super useful. I think I still think having the base components in place to allow us to individually do everything, and then adding that as like a composite CR on top is going to be really simple. And it reduces the amount that template CR has to do, because now it can just downstream to a bunch of other controllers that can parallelize everything. So.
Yeah, but the only caveat that I can think of is if something is broken, so maybe a little bit difficult to debug or find the root cause.
Yeah, true.
You could probably use condition to percolate information back up, so that when you describe, for example, and we have utilities to do so, to aggregate conditions from other objects to different objects. For example, the cluster does that to control plane, or the machine deployment does that to machines. So that we aggregate that information up, and the user has to only go look into one place to get that information. So if you want to debug something and you have a failure, like, you could percolate that up and also block the process for other upgrades, because I'm sure that at some point you might want some operations to be sequential. Especially when it comes down to etcd and control plane, you probably don't want to do them at the exact same.
Yeah, that's exactly what I was talking about. So when you do the actual rollout of the entire cluster, you have to have an orchestrator somehow. There are some other implications. There are some compatibility implications, because people, if they do their individual component upgrade, they may not do sufficient compatible test against with other components, because if you really leave all the powers to individual component owner, there's no centralized guys to do the whole cluster-wise validation about all the upgrades. So that's my worry. But I know at the beginning it's not a problem, because I believe in the beginning every upgrade is done by the experts. So they should know exactly what is consequence of doing that. But from the completely wise, from the project wise, we can make such a strong assumption. So I'd like to have some loose assumption, like making the controller more strict on this upgrade process. But I agree, this is a bigger, tougher problem. Maybe we can address later. But I think we'd better keep it in mind when we do kind of design. So I still think we'd better, in the end, we'd better provide a way to do easy upgrade, follow the use a controller as an orchestrator. And I don't want people to build another controller to do this.
Yeah, we had the exact same, we're still having the exact same problem in Cluster API. Like, you have to change a bunch of versions, like in other places, if you want to upgrade a whole cluster. We haven't pushed for the easy button yet, because honestly, like, we take a lot of, we assume user intent at that point, and that's hard to like grasp with CRDs. But I do agree, like that might be like kind of like maybe 1+ year goal, like that, like you want to get there, but getting the foundation in place today is probably the most important thing. So like getting these controllers, like do the right thing first, and then you build on top of it because you can trust them. That's, yeah, that's great.
Cool.
So I had a question about namespace prefix. So
Yeah.
what is it? What?
Yeah, so this is a little bit related to how the syncing works. And I don't know if it sits in this controller or if it sits somewhere else, because we really haven't talked about how the syncing objects works, at least not from the CapN side of things. There's a lot of information on the VC side. But the idea there is in VC, what we do is it generates a prefix based on the namespace that the actual virtual cluster CR is, and then it hashes that, and it basically creates a unique namespace prefix that gets added to every namespace that gets created from a virtual cluster to stop from collisions happening when, say, for instance, the default namespace is created in every single cluster. So when that gets shared down to the supercluster, that prefix gets added to it. Yeah, and so that's the idea there, is to be able to specify those or have them auto-generated, similar to the way that VC works, so that you can have a little bit more predictable namespaces if you want them versus being able to have auto-generated.
But I'm guessing this prefix may be
it's not directly related to CapN. That's the one thing, and I want to figure out how we intermingle those. I'm open to not putting it into these CRs.
Yeah. I tend to think anyway. So I think when we really put VC on it, is kind of we still need a kind of VC CR anyway, because we cannot describe all the VC related field in CapN, which doesn't make sense. So I would suggest move that prefix to the VC CR. And make CapN, self-contained.
I like that. Works for me.
So it's just like, we need to refer a little bit later. So the VCCR need to refer to a cluster CR, but that's fine. So the VC controller needs to do the, coordination with VC object to the cluster CR, which sounds like one more layer compared with currently we don't have this layer, but which is completely fine to me.
Yeah, that makes sense. Which will actually be good, because that will make it so that it's supported across all the components that VC already has, and we don't have to do much work. All right, is there anything else that anybody wants to bring up? We have roughly 9 minutes left. Cool. Well, thanks everybody. This has been fantastic. A lot of good conversation, and we've been up and down on the amount of content we have. So I'm super stoked to have all of this. Thanks everybody, and I'll let you all
I think
run free for an extra 10 minutes. Go ahead, Faye.
Yeah, just give a wrap up. So next, I think the priority wise is we need to have an NCP design. I think it's kind of okay right now. So because we all agree we start with the simple version. So I think we can start once we make sure the workflow wise, what is exactly workflow. For example, if a fresh people comes to use this CapN, what is a handbook what's the instruction they should follow? It's like a tutorial kind of thing, but we'd better put somewhere formula in the design doc saying, okay, you need to create a raw CR first, and what would be expected? Like, PKI is going to be created, and the NCP controller will add our own reference to the thing, and the rest component controller will generate the exact component part for you. And just get it ready, and think we can move on to at least start an NCP controller, because I think we need to get this PKI stuff done to unblock the rest of the thing. If the PKI is kind of ready, the rest of the thing seems straightforward to me, like the API server controller and the controller manager controller. I just want to give a kind of quick wrap up about what should be the next steps.
Yeah, Agreed. I added that as an action item at the bottom. So there was a bunch of notes that need to get added into that NCP doc as well. Cool. Yeah, and if you want to, just if you can, if there's anything you want to call out as in that doc as well, add them as comments, and I'll make sure that all those get addressed. Cool. Thanks, everybody. All right. Have a great rest of the day.